Welcome everyone to this lunch and learn session together with Cate Hoedemaker, who is the director of the Maritime Battery Forum. Do I pronounce that correctly, Cate?
Yeah, that's correct.
It's a beautiful name, and you've been director of the Maritime Battery Forum for how long now?
For almost 2 years now.
2 years. Wow. So that's a long time, and I think from what you've told me in those 2 years, we've seen quite a lot of growth, not just of the forum itself, but also in terms of batteries, etc.
Exactly.
And I think that's what we're gonna discuss today. Seep gave me some time ago this well, you can't really see it correctly, but a beautiful overview on well, essentially, it's a sort of a quick guide for to determine your battery, the best battery type for your ship. A simplified guide, but this simplified guide alone, 2 papers worth, already contains so much information that yeah, we just had to take the time to go into it more thoroughly together with you, the audience. So the coming session, we'll get a presentation from SEEP, and we'll see how deep we can dive into the world of maritime batteries. So,
Okay. So let's get started. Which battery for your ship? We're all talking about lithium-ion batteries at the moment, but it's very important to understand that there are a lot of different types of lithium-ion batteries that we're using on board our ships and all other applications. But first, a little bit about the Maritime Battery Forum. We are an organization on a mission to accelerate the adoption of safe maritime battery solutions to enable emission reductions. And our vision is to be the leading neutral advocate for maritime battery technology globally. So how do we do this? Is by creating a platform for sharing knowledge, best practices, experience. We try to reduce barriers, financial barriers, regulatory barriers, and knowledge barriers by educating people and by facilitating an arena for collaboration on technology development, standardization, and increasing safety. So by doing all this, we're building a global network of maritime battery enablers. We base all that we do on 5 main topics. To start with battery technology, so we inform people about the latest updates on battery technology, new trends in system design. Then we look at ship and port electrification, so we discuss different use cases for batteries on both on ships and in ports. And we keep track of the development of the market through our ship register, which is a database of all the battery-powered ships in the world. We have a strong focus on safety, so we bring companies together to collaborate and try to improve the safety of batteries on board ships, and by sharing lessons learned from incidents with batteries on board ships. Then we also look a lot at containerized batteries. We try to accelerate the adoption of swappable batteries, and we do that by promoting standardization for this technology. And last but not least, we want to make sure that what we're doing in this transition is moving us in the right direction. So we look a lot at recycling and second life applications for batteries by developing a closed loop for batteries and connecting battery owners with recyclers. So that was a bit about the forum. Now let's move to batteries for ships. If you are wondering, can all ships use batteries? Then my answer is yes. Here you see a picture of currently the largest ship with the largest installed battery capacity in the world. It's Aida Prima cruise ship with about 10 megawatt hours of batteries. And in front of it, you see a very tiny water taxi that also has batteries. Now, basically anything in between these two ships can use batteries as well. Everyone thinks always, of course, of ferries. So you have smaller urban ferries, larger ferries, even fast ferries on batteries now, but also tugboats, offshore supply vessels, ro-ro cargo vessels, fishing vessels, container vessels, and the offshore wind industry is also very interesting for batteries, because if you produce electricity offshore, why not charge your batteries with electricity that you produce in the area that you're operating. So as you can see, many possibilities for batteries on board all different kinds of ships. And all these ships have different requirements for their batteries. So why use batteries on ships? Well, of course, first of all, zero emission sailing. That's where we want to move to in the end. But it's not just fully battery powered ships, it's also hybrid battery ships. So we try to increase energy efficiency, decrease fuel consumption, but batteries can also be used to reduce the maintenance on board ships. So by replacing rotating equipment and like diesel engines, replacing them for electrical equipment can reduce your maintenance cost. But also adding redundancy to your propulsion systems is something that a battery can achieve. And there's different ways of doing this. So as I said, full electric sailing is just using the batteries for sailing completely. Then we move to the hybrid use cases for batteries. So peak shaving, for instance, is where you can install a smaller generator or a smaller engine, and whenever you need more than the maximum of the power the engine can supply, the battery kicks in. But also load leveling is where you can operate your generator at exactly a constant load to make it run as efficient as possible. Then whenever you need more, the battery kicks in, and when you need less, the battery can be charged. Spinning reserve is where you use the battery as a backup power supply. This is very common for dynamic positioning ships. Instead of having an extra online generator, you can replace this generator by a battery. Then boost function and ramp support are both two different ways of increasing the performance of your ship on a shorter period of time without having the need to install more power for your engines. So as you saw, most of these use cases are for hybrid propulsion systems. So if we look at the total fleet of battery powered ships in the world, about half of these ships have a hybrid propulsion system. 25% are pure electric, so they only have batteries, and the remaining 25% is plug-in hybrid. So again, then it's battery combined with diesel engine of some sorts, but then also the option to plug it in and charge the batteries at a dedicated charging station. If we look at how this developed since 2010 until last year, the first years where people were starting to put batteries on board ships, the majority was looking at pure electric, so only using batteries. But quite soon, the hybrid propulsion systems were becoming more popular, and it makes sense because of all the ships in the world, most of them are more suitable for hybrid propulsion than just batteries alone. Now, more recent years, with the development of charging systems and shore power installations, the plug-in hybrids are becoming more interesting as well, and you see that in an increase of installations. So now we talk about hybrids, we talk about batteries combined with diesel engines or generators. But we see a very important role for batteries as an enabler for other zero-emission technologies. So we hear a lot about hydrogen fuel cells, methanol, ammonia, and batteries can be used as an enabler for these kind of technologies, because these alternative fuels, they will be very expensive. So you want to use as little as possible. These fuels have a lower energy density compared to diesel. So if you want to have the same range or keep your operational freedom, you want again to use as little of this fuel as possible. Then if we look at the peak demands in power, for instance, for hydrogen fuel cells, they will always rely on a battery to deal with these peak demands in power, and therefore use electricity in its in its stable form and charge a battery and power a ship using that energy, that is the most efficient way over the whole supply chain of this energy. So then we come to the more important stuff. So which battery do you choose for your ship? Well, first I'll tell you a bit about the different types of lithium-ion batteries and their different characteristics. Then where to start when sizing and selecting batteries, and what are the main points to decide on. So a lithium-ion battery basically works with lithium ions, the yellow little balls that you see here, moving from a positive electrode to a negative electrode and the other way around, depending if you're charging or discharging. And you might have heard of the different types of lithium-ion batteries. The three most common used in the maritime industry are NMC, LFP, and LTO. So these are all lithium-ion batteries, but they use different materials to produce these batteries. And NMC stands for nickel, manganese, and cobalt. LFP stands for lithium iron phosphate. And those two types, they get their names from the materials used to make the positive electrode. So NMC and LFP is used on the positive side. These two types, on the negative electrode, they always, most of the time, use graphite. LTO batteries, they get their names from the negative side, actually, where they use titanium oxide. And on the positive side, usually they have NMC as positive electrode. But this is to give you a bit of an idea like where these names are coming from. And these different recipes for batteries, they result in batteries with different personalities. So the personality or the characteristics of batteries, they are usually indicated by these six different things. So of course the energy density, how much power the battery can supply. The costs for the batteries are very important, of course. How safe the battery is, the lifetime potential of the battery, and how sustainable the batteries are. And what is very important to understand that if you want to improve one of these characteristics of the battery, you're going to give in on one of the other characteristics. So you cannot make the perfect battery that is very good at everything. And that's very important to understand, that if you select a battery, you need to understand what is most important for your application, and I want the battery to be specialized in that. Then those were the battery cells. Battery cells go into a battery system, and that you can put on board your ship. So there are different types of maritime battery system designs that offer different ranges in flexibility. How flexible can they be changed to exactly fit what you need on board, and how easy are they to integrate? So do you have a small ship with a small, strangely shaped room for your batteries? Then you want to have something flexible that you can fit in that small battery space. If you have a very large ship, you can use something that is easier to integrate. You just have a nicely shaped room where you don't have to think about too much if it fits or not. So all these different battery cells, different battery system designs, they result in different specifications for batteries. Here you see the typical energy density for maritime battery systems compared to their maximum continuous discharge power. So their energy compared with their power. And we divided them in three different ranges. So you have the high energy batteries, the medium energy batteries, and the high power batteries. But as you might see here as well, is that there are high energy batteries that have the same energy density as some high power batteries. So it's very important to understand what is being meant with high energy when someone tells you they offer a high energy battery, because it's always relative to something. And yeah, high energy doesn't always have to mean that it's the highest energy for your application. Then cost is something that we're always worried about. Of course, we want to not pay too much for our batteries, but you should not always look at the system cost. So system costs for batteries are always indicated in euros per kilowatt hour. But you should also look at the cycle cost. So that's how much do I pay for every cycle that I want to make with the battery. So it's related to the lifetime of the battery. And here you see an overview of typical price ranges for maritime battery systems. On the horizontal axis, you see the system cost, but the vertical axis, you see the cost for every cycle. And you see that some of the systems that have a very high system cost, they are actually quite cheap if you look at it per cycle. And that has to deal with the differences in expected lifetime for batteries. So the lifetime depends on how many cycles you can do with the battery, but also if you will just store a battery and not use it, it will lose capacity over time. So it is also something that can be expressed in years. It's always a combination of the two, so number of cycles and the lifetime in years. And different types of batteries, they can do different number of cycles. And what you can see on the right here is that what is affecting the number of cycles that you can do with the battery is the depth of discharge. So how large is the discharge that you do with your battery compared to the total installed capacity. And one important thing to see here on the right is that both NMC and LTO, the smaller your cycle is, you can do significantly more cycles. And LFP doesn't really show this behavior. So one strategy, if you want to have a battery that can make a lot of cycles during its lifetime, is to use it for making microcycles. So let's say 10-20% cycles every time you use the battery, so to make sure that you're able to do the number of cycles that you want. All these things, they result in different sizing strategies. So you can for different types of batteries, you have to stay away from the upper voltage and the lower voltage, because that will reduce the lifetime. Some batteries, that's the top and bottom 5%. Some batteries, it's the top and bottom 10%. For others, it's 20%. And then the energy remaining between those boundaries, you also need to take into account the aging of the battery. So how much capacity am I going to lose during the expected lifetime of the battery? And then what's left is your usable energy at the end of life. So if you're sizing your battery, that's the energy that you need to know that you need for performing your operations. And if you don't have that energy available anymore, you can say your battery is at its end of life. So these different batteries result in different sizing strategies, and you can come to these sizing strategies by, first of all, defining your operational profile. So you want to write down, like, what are the different parts of your ship's operation, how long do these different parts take, what's the power that I need on average for this operation, and then calculate how much energy do I need for every of those operational steps, and then the accumulated energy. So how much energy do I need for this whole operation? And then you start with defining the normal operating conditions, of course, but it also can help to define the operations in different scenarios. So what if it's light operations, heavy operations, or maybe in some emergency situations, or maybe your ship can perform two completely different sets of operations, so you will have secondary operations. And then there's 4 things that you want to know before you start sizing or selecting batteries. And that's to start with the minimum required energy. So that's the minimum required energy at the end of life that you really want to have, because if you don't have enough energy anymore, you cannot do with your battery what you want to do. So in this case, the minimum required energy is the 300 kilowatt hours that you need for this one cycle. Then of course you need to know the discharge power and the charge power. You need to know what is the maximum power that I want to charge or discharge my battery with, to make sure that the battery is capable of supplying it. And then you want to know the number of cycles. So how many cycles of these am I going to do per day or per month or per year? And then how many years do I want the battery to last? To give the battery manufacturer an idea of what you're asking of the battery. So then the next step, if you know these four things, you've defined your operational profiles, is to send your request to a battery supplier. And it's always important to send exactly the same request to different battery suppliers so that they can make a calculation that is fitting really their battery technology. And you also might want to add some additional requirements. Like, do I have any weight restrictions? I do not want the battery system to weigh this more than this, because otherwise it will mess with my stability. What are the dimensions of the battery space? That can be very important to know. But also, what is my required lifetime? Do I have any preferences in cooling systems? Do I want a liquid cooling system? Do I want an air-cooled system? Or is that up to the battery manufacturer to decide what they think is best for their batteries? And what are the electrical specifications? So how do you plan on integrating it into your electrical system on board? What are the voltage ranges? What are the maximum currents that you can deal with on board? So then, which battery for your ship? So what are then the most important things to consider when you get your answers from the battery suppliers? Of course, cost is something that you always start looking at, but make sure that you look at the cost combined with the lifetime of the battery, so not just the initial cost of buying the batteries. And make sure that in your cost calculation you include all the auxiliary equipment that you need for the battery. So the cost for the cooling system, the cost for any safety systems like firefighting or ventilation or gas detection, because this might be different for different types of battery systems and therefore will have an impact on your overall cost. Then weight and volume. So again, calculate this for the complete system, so including your cooling systems, your safety equipment, and make sure that it actually fits in your battery space and that you can still walk through your space if everything is in there. Does the performance of the batteries match your requirements of your ship? So look at the electrical requirements. Does the voltage range of your batteries fit within the voltage range of your converters or DC grid, whatever you have on board? And what are the current limits? Can I use the power that I need from the batteries along their complete state of charge range or voltage range when the batteries are fully charged or fully discharged? Will they still work? And what is the efficiency? Do I need really a large amount of cooling to keep these batteries at the right temperature, or can I install a relatively small cooling system which improves the overall efficiency of your systems on board? And safety. So what is needed in combination with the different battery systems to design a safe battery space? Different batteries will have different IP ratings, different solutions for off-gas treatment. So you will need different installations for ventilation and gas detection. So all these things are important to understand when you're designing your battery space to be a safe environment within the ship. And that might be different depending on the battery system design. So that was it. Thank you very much. And yeah, let me know if you have any questions.
Well, thank you very, very much, Sip. I wrote down a few questions. I got a whole A3 page full. Before you dive into them,
Should I
yeah.
stop sharing my screen or?
Well, maybe not, because I have a few questions regarding the slides. So then we can go back to those slides in particular. But first of all, I got to say, beautiful overview of all the ships. Each time that not only I speak with you, but I speak with others involved in the electrical or the maritime battery sector, you could say, the pictures accumulate and become prettier every time. So it's always fun to see. And maybe for the people viewing this, that they should also know that I have quite a bias in favor of batteries, because I think over the last few years it has progressed enormously. There's so much innovation going on, and at a speech recently from DNV about alternative fuels, it was stated that every vessel in the future will have a battery. I totally concur in that one. So there's so much potential and also so much work to do, as you are quite well aware, I'm sure. Enough about me. First of all, if we go back to the difference. That's maybe a very technical question. It was the battery application slide. So you had the 7 different applications.
Yes. This one.
This one, yeah. Most of it is now quite clear. I had a few questions on it, but I still have a question on the exact definition between peak shaving and boost function, because in essence, you sort of do the same or not?
Um, yeah, but here it's more about the duration of the
Mm-hmm.
of the battery kicking in. So peak shaving is really used for shorter bursts of energy, while load leveling is more over a longer period of time. And then, what is that limit between peak shaving and load leveling in, boost function in a period of time? I couldn't really say what the limit is, but let's say one is talking about seconds, the other one is talking about minutes.
Yeah, right. And that's maybe also up to the battery supplier to, in terms of terminology.
And exactly, everyone will have different definitions of the different
Exactly.
applications.
Okay. No, but now it's clear. Full electric, well, that speaks for itself. Spinning reserve, like you said, DP, peak shaving and boost function when you need additional power for your engine. And then load leveling, make sure that your engine is constantly running on the same load and your battery just charges and discharges. And then we have ramp support and load. I also have load smoothing now, by the way.
Yeah,
That's
indeed. That's on the sheet, but not on this slide. It is again. Then it's a question about the time period of the fluctuations. With load smoothing, you're talking about more milliseconds probably. It's more a function to stabilize your electrical grid, and it's more an aesthetic thing why I chose to to use these
okay.
6 functions. It's they're basically the same. It's just different periods of time for
Okay.
the fluctuations.
Yeah, and is there also a difference in the averages? Is there like, for instance, load leveling is just an average power demand, and then load smoothing, which we don't see here, that fluctuates a little, or is that arbitrary?
Yeah, that will be very much depending on the application. Yeah.
Yeah. So maybe at this point we would have to talk to the specific supplier in order to get the full operational profile. But
Yeah.
this already clarifies a lot. Yeah. Yeah, you mentioned shortly, I think it was on the next slide, on the amount of pure electric. Yeah, this one. So hybrid versus pure and plug-in. Yeah, and I think you mentioned it, but I wanted to dive a little deeper on the reason why pure electric was used so much in the beginning, because this doesn't state the ship types. That would also be a nice sort of
Hmm.
comparison. But
Yeah.
is there a change in that? Maybe ships have or hybrid ships are now made bigger, for example.
Yeah, so if you look at the ship types, most of these ships 10, 12 years ago that were pure electric were small ferries, small ferries or small tourist vessels. Um, so not a lot of energy and power requirements, and it's basically because it was the easiest thing to do. Making a fully battery powered ship is a lot easier than making a hybrid ship.
Yeah.
Um, so that's why it made sense that in the beginning, let's make it fully battery powered, because then you don't have to worry about how the battery and the diesel engine or
Yeah,
generator is
yeah,
going to work together.
yeah. I see. I see that. Yeah, yeah. That's actually what I hear from especially vessel manufacturers as well. That you just simply have less. Well, hybrid, you have double the equipment. Nah, not really double, but two times the systems, basically.
Yeah, so it's more equipment, but the equipment needs to talk to each other, and that's the most challenging to do is how do these different components talk to each other, and how do they complement each other in the best way that you use the right source of energy at the right time.
Yeah, yeah, yeah. It would also be nice to see the total amount of electric propulsion system. I don't know if you have that handy or.
So I don't have that slide here. So in our database, there are currently about 800 vessels, but I'm working on a big update. Um, and yeah, we're currently at around 1,000 battery-powered vessels around the world.
Nice. So that's approaching the 1%,
Exactly.
roughly. Yeah. Okay. So, are there any cases you can imagine when you would not recommend a battery per se for a vessel or ship types?
Well, it is definitely possible to design a hybrid propulsion system that is less efficient than just a diesel direct system.
Yeah, yeah, yeah.
I have seen examples where batteries were installed pure for the idea of having a battery making my ship greener.
Okay.
But if you do it in the wrong way, then you're using more fuel than if you would just use diesel.
Uh,
Um, so I don't think, or I think that all ships potentially can benefit from a battery when the system is designed in the right way.
yeah.
Yeah, but you can definitely do it wrong.
So then you really have to dive into equipment losses, inverter losses, types of or types, the voltage in on switchboards, etc. But that's
Yeah.
almost more of an electrical issue than a battery issue.
Yeah, and it's very important to understand the operations of the vessels and how is the vessel going to be used. So it's not just am I designing the propulsion system the right way, but is the crew going to use it like
Oh
I
yes,
designed it?
yeah,
That's also another challenge. You can design a very complex and innovative propulsion system, but if the crew uses it in a completely different way, then yeah, you
yeah,
might end up with a situation that is less optimal.
exactly. Yeah, and judging by the way you say this, you've heard these cases, or at least one case.
Yeah, for instance, batteries can be used so that you can turn off all the generators and the crew can sleep in a completely
Yeah,
quiet ship.
yeah, yeah.
But if the batteries are designed for sailing, using them for sleeping is not always the best option.
Okay, got it. Well, but for the crew, maybe. I mean,
For the crew, it's the best option. Yeah,
yeah, yeah, yeah.
exactly.
A night well rested also counts for at least something. Um, yeah. Moving on to the next slide, or I don't know if it's the next slide. It's the cost slide. including the
this one.
yeah, exactly. So we see system cost versus cycle cost. That's clear. So we have between 400 and a little bit over 800 euros per kilowatt hours, and then cycle cost between 50 cents and 30 cents per kilowatt. But is it also kilowatt hour?
So these cycle costs are calculated based on 80% depth of discharge cycles at 25 degrees Celsius, which is not a very practical cycle that you will see on board a lot of ships, but it is a standard cycle that is often used to indicate the number of cycles a battery can do. So it's not that you will pay between 5 cents and 35 cents per cycle on your battery system on your ship, but it's just based on a normalized calculation based on those 80% depth of discharge cycles to be able to make a fair comparison between all the different batteries. If you would really look into differences for microcycles, for instance, if you look at the 10% cycles, this picture will change.
For the better or the worse?
For some batteries it will be better, for other batteries it will be worse.
Of course. But that 80% discharge you were speaking about, that's more of a maybe industry standard, a way to compare cells individually.
Exactly. It's what most battery cell manufacturers provide in information regarding how many cycles you can do with their batteries. In real life, it's the whole aging of batteries and number of cycles you can do is a lot more complicated and is depending on a lot of different things, especially in real life applications like a ship.
Yeah. Well, I've never heard that real life is more complicated, so that's a first. Just kidding. And so the outliers that we see here, both ways, does that have to do with cell chemistry or something else?
Not per se. So some of the outliers can also mean that these batteries are specialized in something very specific. So that I know, for instance, the one with really the highest cycle cost, I believe that's one battery that has a very high power rating. So you can really charge them in just a matter of minutes, which might be interesting, but so you will have a more expensive battery, will probably also be a bit heavier, and then you have to challenge, can I actually build a charging system to charge my battery for my ship that fast? So these outliers, it doesn't have to mean that it's not a very interesting battery for your ship. If your ship would really benefit from having high charge powers or discharge powers, then it might still make sense to install this more expensive battery.
Yeah, of course. Again, real life making it more complex, but
and this is actually something that we'll see more and more with the development of new battery technologies. So now it's all about lithium ion, and then you have the different NMC, LFP, LTO, but those are being different. So not all NMC batteries are the same. You also have a lot of different types of NMC batteries, and with future developments of batteries, we'll see a larger diversification of what they are meant to do. So you will get batteries that are getting better and better at doing a lot of cycles, for instance, but you see batteries that will have a increasingly higher energy density, and there will be batteries that are really designed to be as cheap as possible. So this spread will become larger and larger, making it even more challenging to select the right battery for your ship.
Got it. Well, that's what we have you for, of course.
Exactly.
Then maybe the last question about the slides, or maybe not even about slides. Is there a reason to prefer a liquid or an air-cooled system?
No, I think it's mainly depending on your operational profile. So how am I using the battery? Um, the the higher the power on the battery, the more heat it will produce. So the more cooling you will need to keep it at a comfortable temperature. Batteries are a bit like humans. We like to be between 20 25 degrees Celsius. So that's where you want to keep your batteries. Um, so it's depending on how are you using them, but it also depends on your system design. So that's more up to the battery system manufacturer, if they have their own reasons to use liquid cooling because they want to cool the battery as efficient as possible,
Yeah.
that might work. But you can also say air cooling might be sufficient for my type of battery. So why would I put extra effort in making it a liquid cooled system?
Yeah. Yeah. Got it. Got it. Okay. Well, I think that covered the slides mostly. So yeah, we can now focus on each other. Now I have a few more questions on more of the macro side of things. You touched upon recycling,
Yeah.
and one of the most common questions or remarks, I should say, from people not always very well versed in batteries, or well, you can, or let's just put it what it is: the more the hydrogen enthusiasts or the alternative fuel enthusiasts. They usually state, apart from safety issues, which hopefully we can discuss a little bit, the recycling issue or the amount of resources issue. Is there an issue? Can we recycle batteries or not? What are the developments in that area?
Yeah. So actually, batteries can be recycled very well. 2 weeks ago, I visited a battery recycling plant in China, and they showed me how they can recycle, if I remember correctly, up to 93% of the lithium in the batteries, and around 98% of the, and this was planned for NMC batteries, so 98% of the nickel, manganese, and cobalt.
Okay.
So that's quite a good score, I would say. They told me that they needed to recycle above 90% of the materials to make it worth it in cost. The cost is the biggest challenge right now.
Yeah.
It's still expensive to recycle batteries, but they're getting those costs down, and quite soon it will actually yeah, bring money to you if you recycle all batteries for the new materials, and then you can use those materials to make even better batteries than where they originally came from.
Haha, cool. Okay, but and what about those last few percentages? Is that because of heat loss or whatever, or can it be improved?
Yes, of course, everything can always be improved,
Yeah.
but then you're going really into the chemical reactions, and so then my knowledge stops a bit. I know that there's different ways of recycling. So you have um, uh, the pyro, so then they actually burn it, and I don't know exactly what magic they put in it to get the materials out of it, but
Yeah.
it looks a lot like magic to me, having not a background
Yeah.
in being a chemical engineer or anything like that.
Yeah. Well, of course, for the average ship owner, it doesn't really matter.
No, exactly. I think the important thing to know is that it is definitely possible to recycle batteries, and that's also what we're trying to do as a Maritime Battery Forum, to connect ship owners
Yes.
when their battery is at their end of life. What do they do with it?
Yep.
There are plenty of recycling companies that actually will be happy to help you with getting rid of your old batteries, and then you can get new batteries for your ship again.
Yeah, yeah, beautiful. So now it's, let's say, 93% for lithium, up to 98% for NMC possible.
So yeah, so depending on the technology that you use and the recycling company one, yeah, it's
That's a thing or two to say about it. Yeah. Now, okay, but so recycling can still be improved, but already is quite on par with.
yeah, the biggest challenge, especially here in Europe, is the capacity for recycling.
Yeah.
There's a lot of batteries about to reach their end of life, and especially in Europe, we do not have enough recycling plants to deal with all of this. So that's why um, first you'll see probably quite some second life applications. So using old batteries to use them in battery systems that have easier requirements. So um, yeah, longer term energy storage, lower powers, and then use the batteries for a second life and get some more value out of them before you go to recycling.
Yeah, got it. And then maybe another sort of a hard question. What about another common theme you hear is like child labor, slave labor, especially the cobalt is an issue.
Yeah, yeah.
What can you say about that?
So that's a very difficult situation, especially for cobalt. Um, I don't have exact numbers on the child labor that is occurring in these cobalt mines, but it is definitely a thing, and it's something that we really shouldn't want. Of course, we want to use batteries to go through a transition to make the world better, but we need to make sure that we make it better for everyone.
Yeah.
So what is being done within the battery industry in general is looking at creating a battery passport. So making sure that it's known which material, excuse me, which materials are in the battery and where these batteries are coming from. So that's both for yeah, making sure that you can identify batteries that definitely do not have cobalt sourced from mines where children are working,
Yeah.
but also for upcoming regulations that certain percentages of the materials used in batteries need to be recycled material.
Yeah.
So that's something that's being developed by the international battery industry, mainly driven by the automotive industry. As maritime industry, we are too small to really have a say in that. So we'll just probably just have to wait till what to figure out what they decide, and then hopefully use the same.
Tag along and see. Yeah, well, or yeah, there's a lot of overlap between EVs and ships, of course, but still also a lot of differences. So it might be.
We use a lot of the same battery cells, but yeah, they need a lot more than we do. So
Yeah.
we can just wait a bit till they solve the biggest issues.
Exactly.
And,
Exactly.
they can push us forward.
Got it. And then my final questions are regarding safety. Is there for the ship owner any recommendation you can give on maybe cell chemistry type or different application types or anything to improve safety? I won't say improve or reduce, but let's say improve safety.
So you might have heard people saying that LFP is safer than NMC or LTO is safer than NMC. It's depending how you look at it. All these different lithium-ion types, they can still, if they are overheated, if there's a fire on board, they can result in quite a big problem. So it's not just based on the chemistry. It's about the complete picture of how are these cells integrated into the battery system. So how is the battery system designed? But also, maybe even more important, how do you design your battery space? If we look at some of the incidents that have happened with batteries aboard ships in the recent years, it was always an external factor that caused the incident. So it was maybe water coming into the battery space, and so we can change our requirements for battery systems to make sure that those incidents don't happen anymore. But it is very important to also look at your ship design and the design of your battery space to make the overall thing safe. So you shouldn't only look at protecting your ship and your crew from the batteries, but you also need to protect your batteries from other things that might hurt the batteries.
Yeah.
So I think that's why it's very important to really focus on education of people, ship designers, shipyards, and crew to understand how to deal with with incidents on board ships.
Got it. Yeah. I guess you could say I'm also one of the people saying that LFP in general is safer than NMC, but it was my understanding that it has a lower. What's the word I'm looking for?
So
runaway thing.
the depending on the temperature at which the battery goes into the thermal runaway, you can say if it's safer or not. And if I would have a let's say cheap designed battery system, I might prefer to put LFP cells in them compared to NMC. But I think that's why it's important to look at the overall picture. You can make a battery system on board your ship with NMC cells that is just as safe as a battery system with LFP cells if you design it in the right way.
Got it.
So whenever a battery manufacturer says that their system is the safest, as not really true. They're all equally safe if you design the battery space in the right way.
Take it with a grain of salt. Okay. All right. Well, I've learned so much. I think the main takeaway there's a lot I'm gonna take away from this, but I like the batteries are a lot like humans part. They like to be kept in a certain temperature. They're gonna have a passport in the future as well. Can be recycled. I don't know if that applies, but always room for improvement. No, but honestly, I think not just for me, but hopefully for people seeing this, it's so much information. And I think in the future, when they need more or like to apply to the Maritime Battery Forum, they can of course reach out to you, see what's possible.
Yeah, exactly. Our whole goal is to share as much information as possible to make everyone aware of the different types of batteries and how to put them on board ships. So we're always happy to help with whatever questions everyone has.
Great. Thanks, Siep. Thanks for your time, and we'll speak again soon.